All right, so this is all of the recording for week 7, since we're a little behind in terms of recording because of the holiday. So let's take a look at this. This is a type 1, type 2 error question. And so this question begins with a consumer advocacy group is doing a large study on a car rental practice. Among other things, the consumer group would like to do a statistical test regarding the mean monthly mileage mu of cars rented in the U.S. this year. The consumer group has good reason to believe that the mean monthly mileage of cars rented this year is greater than the last year's mean, which was 2,800. So the group plans to do a statistical test regarding the value of mu. It chooses a random sample of monthly mileages and computes the mean of the sample to be 2,935 miles and a standard deviation of 800 miles. So based on this information, we're going to complete the table with A, B, C, starting with A, what are the null and alternative hypotheses, and that should be used for the test. So when I look at this question, the first thing, having read it, tells me immediately, let's see here if I can pull up my notebook so I can write it down for you. Let's go here and let's go here. All right, so based on this information, I feel comfortable with saying that mu, in this case, is equal to 2,800. And this would be the null hypothesis, obviously. So this is your HO, or your null. In the HA, we would say that mu is greater than 2,800. All right, so that answers part A. Part B. It says, suppose that the group decides to reject the null. They decide to reject the null. So what type of error would they be making? Well, see, understand that a type 1 error has to do with rejecting the null. So for this question, I would say a type 1 error. I can't drop down the menu because I'm in teacher mode. But if I drop this down, it will give you a choice of type 1 or type 2. So if you're dealing with rejecting the null, then this would have to be a type 1 error for part B. Remember, type 1 error has to do with rejecting a true null. Reject the null hypothesis when in fact the null is true. That's why immediately once you see the reject the null, you know it's a type 1 error. In part C, it says, suppose the true mean monthly mileage of cars rented in the U.S. this year is 2,800. So we would need to fill this in. We're going to describe a type 1 error. This would be so much easier if I could, once again, have you guys on the screen on the call, because you could drop down your menus and I can see based on the choices. But a type 1 error would be to reject the null. So that's the first drop down you would choose. When the hypothesis that mu is, and then according to this, the mu would be equal to 2,800, but you reject the null. Reject the null, that would be the third drop down here, when in fact mu is 2,800. So that would be the type 1 error. In other words, I say it or simplify it to stating something to the fact of, hey, you rejected the null. That's like rejecting the truth. And the truth is that the null is the truth at mu is 2,800. Okay? All right, so that's one example. To take a look at that, just sort of marinate it and see if it sinks in. Let's do another one. All right, in this question, they're stating a somewhat outdated study indicates that the mean number of hours worked per week by software developers is 44. We have good reason to suspect that the mean number of hours worked per week by software developers mu is now less than 44 and wish to do a statistical test. We select a random sample of software developers and find that the mean of the sample is 41 hours and that the standard deviation is 5 hours. So what are the null and alternative hypotheses for this? Okay, so let's again narrow this in. So for this question, let's see, for part A, we would say in this case that mu is equal to 44. And for the alternative hypothesis, we would say mu is less than 44. Remember, the null hypothesis, this is the null, always has equal to built into it. The alternative hypothesis never has equal to in it. So here's your HO, and this is your HA, respectively. All right, in part B. Part B, it says, suppose that we decide to reject the null hypothesis. So what type of error would we be making in this case? So we reject the null. Because we're rejecting a null, there's a chance we're making a type 1 error. Right? Because it's all about rejecting the null. Now we get to part C. In part C, it says, suppose the true mean of hours worked by engineers is 39 hours. So we want to fill in the blank to describe a type 2 error in this case. So in a type 2 error, we would say a type 2 error would be failing to reject the null hypothesis that mu is equal to 44. When in fact mu is less than 44. When you drop down the menu, one of the options is the inequality. If you notice that a type 2 error, as stated in the notes, so type 1 error is rejecting a null when in fact it's true. A type 2 error, so a type 2 error is failing to reject a null when in fact the null is false. That's the simplest way I can state that. All right, so that's type 1, type 2 error. That's the first type of question you have. All right, ladies and gentlemen, the next type of question that you're going to have here is very simple. It's just determining the null and alternative hypothesis. So I'll do a few of these. It says a coin-operated drink machine was designed to discharge a mean of 8 ounces of coffee per cup. Obviously that's equal to, so that's mu is equal to 8. And now look at the next sentence. It says, suppose that we want to carry out a hypothesis test to see if the true mean discharge differs. Okay, when it says differs, it's simple. It's just not equal to 8. So you would write for this one, mu is equal to 8 ounces. That's your null hypothesis. That's your HO or your null, right? HA, or the alternative, which is also known as H1. So this is the alternative. Because it says differs, whenever you see the word differs, there's no greater than, no less than. So that means that the hypothesis is mu is not equal to 8 ounces. Could be less than, could be more than, we don't know. All right, let's take a look at the next question. Okay, again, in this question, if you notice the wording, it says cholesterol levels of adult males are approximately normally distributed with a mean of 225 and a listed standard deviation of 21.8. So some researchers claim that the standard deviation of cholesterol levels of adult males is less than 21.8. Suppose that you want to carry out a hypothesis test to see if the actual standard deviation of cholesterol levels of adult males is less than 21.8. State the null and alternative hypothesis. Again, so they're telling you that sigma, so the null hypothesis is that sigma, did they say sample? They didn't really specify it either way. I'm just going to go with sigma is equal to 21.8. Remember, if it's a sample, usually they'll use S of X, and if it's a population, they're going to use sigma. But they didn't really specify. They said of adult males. I'm going to go with population, so leave it at that. The alternative hypothesis in this case is that it's less than. So sigma is less than 21.8. All right, and that takes care of that question. So this should be fairly easy for you. I'll do another few. Let's see here. On this one, it says the records of a casualty insurance company show that if in the past its clients have had a mean of 1.9 auto accidents with a standard deviation of 0.05, the actuaries of the company claim that the standard deviation of the number of accidents is no longer equal to. Doesn't say greater than, less than, so this is a not equal to. Equal to, not equal to. So you would say again in the first argument that the mean, or the null hypothesis here, that the standard deviation is equal to 0.05, and the alternative hypothesis is that sigma is no longer 0.05. We don't know greater than or less than, we just know it's no longer that. All right. Okay, so this next type of question takes a little bit of patience, okay? So it's 5 parts. It's all connected. All body parts are connected, so please pay attention. And if you're tired or if this is getting to you, just get up, close the computer for a minute and walk away and come back to this because you need concentration here. Okay, so the breaking strength of cables produced by a certain manufacturer, they have a mean of 1,800 pounds, a standard deviation of 50. So right away I have mu and I have sigma. So let me stretch this out so I can get my notebook back out. Okay. So far they've told you that mu is 1,800. That's our null hypothesis. They've told us that sigma is equal to 50. It says it is claimed that, here's your claim. So the claim is going to be obviously the alternative, the HA, because they already gave you mu. That's the HO. And you know it's an HO because it's equal to, right? So it is claimed that an improvement in the manufacturing process has increased the mean breaking strength. To evaluate this claim, 100 newly manufactured cables are randomly chosen, and they test the mean strength to find that it's 1,811. Can we support at the 0.05 significance level that it has increased? So that is that this is greater than 1,800. Okay, and we know that this is the sample mean at 1,811, and the sample size is 100. It's stated in the question, right? Okay, so let's answer part A. Part A says state the alternative and the null hypothesis. So to answer part A, well, technically we have the answers are right here, where we have mu is greater than, right? Because they're asking if it increased, and mu is equal to. That is your null and your alternative respectively. Remember, the alternative never contains equality. The next question is, what type of test do we use? Well, first of all, you have to ask yourself the question, do you know sigma? If you know sigma, then you know it's a z-test. So our answer to part B is it's got to be a z-test because we know sigma, and it's also a large sample size. So the next thing we want to do is we're going to find the value of the test statistic. So we're going to start with the formula where we have x bar, so this is part C. We have x bar minus mu over sigma over the square root of n. And they gave you some really pretty numbers if you think about it. So we have 1811 minus 1800 divided by the standard deviation of 50. And that is divided by the square root of 100, which we know is 10. Do a little math, and we find that this value is 1.645. Okay, now the critical value. The critical value, no, I'm sorry, this actually is what I calculated for the critical value. Let's do some math here. Grab my trusty little calculator. And so we want to do 1811 minus 1800. So obviously this is 11 divided by 50 divided by 10. So we have 50 divided by 10, which is going to give us 5. So 5 goes into 11. 2.2 z-score. So 2.20 for a z-score. Remember, that's what that is. Now, keeping this in mind, remember that for part D, find the critical value, we're going to do inverse norm or norm S inverse in Excel. If you use Excel, you're going to do norm S inverse, and you're going to put in the point. It's greater than, so 0.95. It's directional hypothesis, obviously greater than directional one-tailed. So inverse of this, and if you use the Alex calculator, in Alex, you're going to use the Z with the little box down here. You're going to put in 0.95 there. All right, and what other options do you have? If you use the z-score table, obviously you're going to look it up by that. I believe that we get 1.645 once we do that. And so remember, there's two things to keep in mind here. First of all, if P is less than alpha, you're going to reject the null. We don't have P and alpha here. We have the OV. If the OV is greater than the CV, we're going to reject the null. And so remember, in this case, your OV is 2.20. That is greater than 1.645. So we're going to reject the null. If I reject the null, that means that the alternative hypothesis is much more, I guess it would say, reliable to us. So can we support the claim that the mean strength has increased? Definitely. So we would answer yes. Because remember, going back to part 1, the claim is the alternative hypothesis. And so we did reject the null. All right, so that's that part. All right, in this question, again, another patient's question, it says the breaking strength of cables produced by a certain manufacturer have a mean mu of 1,925 pounds. So they're telling you, in this case, that mu is equal to 1,925 pounds. They are also telling you that there is a standard deviation of 60 pounds. It is claimed that an improvement in the manufacturing process has increased the cable's strength. So in other words, they're saying that mu is greater than 1,925. We're also looking at a sample size n of 60. So in this case, that helps us start with the question. Can we support it with an alpha of 0.01 level of significance that the mean breaking strength is increased? So here's your alternative hypothesis. Here's your null hypothesis. Okay, so what type of test statistics should we use for part B? Well, for part B, we know sigma. Because we know sigma, we're going to use a z-test. Okay. And for part C, it says find the value of the test statistic. Okay, so we have a lot of information here. We know the mean, so we know that that is given to us at 1,945 minus the 1,925, which is our mu, divided by 60, divided by square root of 60. So do a little math. So obviously we would start with 1,945 minus 1,925, which is 20, divided by 60, divided by the square root of 60, which is 7.745, and it continues a little bit. 20 divided by this is approximately 2.58. I mean, if I round it, it's 2.582. Usually we do z-scores to the second place value here. That's all we need. So this is our OV, our observed value, is what we calculate. In part D, the CV, this is what we look up. So we're looking up an alpha equal to 0.01. So we're going to use in our ALEC calculator a 0.01 in here, or a z with a 0.99. Remember, it's greater than, so we're going to take the positive value, and this value should give you 2.326. This is your CV. Remember the rule of thumb. If the OV is greater than the CV, we're going to reject the null. So in this case, can we support the claim that the mean breaking strength has increased? Yes. Excellent. All right. Okay, in this type of question, I want you to keep in mind this is no different than the previous one. The only difference is that it's a p-value question, not a mu. So as we read the question, it says an administrator at a rural college claims that the proportion P of students who commute further than 15 miles to school is no more or is more than 20%. So to test this, she selects a random sample of 275 students at this college. She finds that 70 commute farther than 15 miles to school. Is there enough evidence to support the administrator's claim at a 0.05 significance level? All right. Here we go. So to answer the first part of the question, let me just stretch this out a little bit so I can see it better. Okay, so the first thing they want is the null and alternative hypothesis. So the claim is the alternative, right? And we know that because the alternative never contains equality, and she's suggesting that the proportion is greater than 0.20. So for the null, we would assume that the proportion is no different. So it's 0.20. The p-hat that is given to us in the question is stated as 70 out of 275 commute further than the indicated amount of 15 miles. So we could change this 70 over 275 into a decimal, which gives us 0.2545, repeating. So I would just leave it at maybe that. So we would use our null and alternative hypothesis, which are stated here in part A. In part B, we obviously are going to use a z-test because our sample size is equal to 275, which is definitely greater than 30. In part C, we're going to use a test statistic. So in that case, we're going to say p hat minus the indicated proportion divided by the indicated proportion times its opposite q, which is 1 minus p, over the sample size 275, and we're taking the square root of all of this, obviously. So in our case, this would be the 70 over 275 minus the 0.20 divided by the square root of 0.20 times 0.80, obviously 1 minus 0.20, divided by 275, and we're taking the square root of all of that denominator. When all is said and done, we should end up with a value of 2.261 once we calculate this. Using your calculators in your Alex calculators or Excel, to find the critical value, you would simply do z of 0.05. And remember, it's greater than, so you're going to take the positive of whatever you got, and I believe you get 1.645. Remember, this is the observed value, this is your critical value. The rule of thumb is, if the OV is greater than the CV, you're going to reject the null. Since I am rejecting a null, it says, can we support the claim? The claim is the alternative that the proportion of students who commute farther than 15 miles to school is more than 20%. And in this case, we would say for part E, yes, we support the claim. So that is basically what you're doing this week. Your examples are pretty straight to the point. It's not difficult. Just stop worrying and try. Just try. All right. And worst case, remember, you can always click on the explanation. So the explanation will walk you through everything that we just talked about. All right. So there you are. Look at that. Look at that. Look at that. Yes, we can support the claim. All right. So best of luck to you this week. Please get caught up because we are starting the second half right after this weekend's. Have a great break.